Dear students, this is the chapter Irrational Number and it is lecture number 1. So, for class 10, prove that root 2 is an irrational number. So, we use the method of contradiction. For this, see here, if possible, let root 2 be a rational number. We have to prove irrational, but we have considered rational. Then finally we get the contradiction. Then our purpose is solved. So root 2 is p by q. If rational, then it will be p by q form, where p and q are integers. Q is not 0 and LCM GCD of pq is equal to 1. Okay. If you square, then it is 2 is equal to p square by q square. This implies p square is equal to 2q square, cross multiplication. This implies p square is even because it is multiple of 2. Q is integer, q square is integer, then 2 times any integer is even. So p square is even. If p square is even, then we claim that p is even. P square is even, this implies p is even, but it is claim. We have to justify this one. So see here, again I have taken the one contradiction method. P is odd. Suppose P is not even, then what will be? P is odd. Then P will be 2m plus 1, where m is some integer. This is the form of the odd number when m is integer. Then P square is 2m plus 1 whole square. And this one is 4m square plus 4m plus 1, do the whole square. 2 common m square plus 2m plus 1. See this form. Suppose m square plus 2m is equal to n. Then it is again in the form of 2n plus 1, where n is some integer. So see, p square is clearly, it is odd. Divided by 2, get remainder 1, means it is odd. So p square is odd. But what is here given? P square is even. So this is not possible. P is odd is not possible. So not possible, this one is. Clear? That is why it is surely P is even. When P is even, then P will be 2k for some integer k. Then P square is 4k square, doing the whole square. Then replace P square by 2q square. Then it is 4k square. Now q square is equal to 2k square. This implies, similarly, one step I have left here. Q square is even. This implies q is even. Same thing. If p square is even, then p is even. If q square is even, q is even. So finally we get q is even and p is even. P and q are both even. Then how the GCD of PQ will be 1? At least 2 will be. So GCD of PQ is not 1. This contradicts this fact. So we get a contradiction when we suppose root 2 be a rational number. So this assumption is false, not possible. So root 2 is an irrational number. Thank you. So see the method of contradiction I have applied 2 times. Thank you.